The date is January 28, 2026. The sun hasn't fully risen over the James River in Newport News, Virginia, when a shadow the size of 3 football fields begins to move. Slowly at first, almost imperceptibly, the steel giant slides away from the pier at Huntington Ingalls Industries Shipyard, the only place on Earth capable of building a nuclear-powered aircraft carrier for the United States Navy. Tugs strain against 100,000 tons of displacement. The water turns white. And standing on the bridge, staring out through the windows at a gray Atlantic horizon, Captain Doug Langenberg watches his ship, his cruise ship, move under its own power for the very first time. This is the pre-commissioning unit John F. Kennedy, hull number CVN-79, the second Gerald R. Ford-class supercarrier ever built. A vessel that carries within its 1,092-foot-long hull more than a decade of labor, more than $12 billion in public treasure, more engineering ambition than any warship program in modern American history, and, in March 2026, a sense of urgency that no Pentagon budget document could have predicted even 6 months ago. Because halfway around the world, the United States is at war. The conflict with Iran, its exact contours still classified, its operational tempo known only to those with the highest clearances, has already forced the Navy to make a decision it never wanted to make. The USS Nimitz, CVN-68, a carrier that first launched aircraft in 1975, a ship that should have been sailing into her final retirement by now, has had her service life forcibly extended. As of this recording, Nimitz is still underway, still operational, her 51-year-old hull carrying the weight of a mission that planners had long assumed would be handled by a newer ship. The decommissioning that was scheduled has been pushed to March 2027, a last-minute reprieve driven not by sentiment but by cold strategic arithmetic. The United States cannot afford to drop to a 10-carrier fleet while missiles are flying in the Middle East. That gap, the space between when Nimitz must leave and when Kennedy must arrive, is the story of American naval power in 2026. It is a story about technology that failed and was rebuilt, about engineers who refused to accept defeat, about sailors who trained for years on a ship that wasn't finished, and about a nation that bet its most powerful instrument of global deterrence on a platform so radically new, so technologically ambitious, that it nearly collapsed under the weight of its own innovation. What you are about to hear is not a press release. It is not a recruitment advertisement. It is the unvarnished account of how the USS John F. Kennedy was built, broken, rebuilt again, and sent to sea, and why, in a world already at war, that ship may represent the most consequential engineering achievement in American military history. The stakes are not abstract. They are operational, they are strategic, and they are measured in sorties, in missiles, and in the lives of sailors who need this ship to work perfectly the first time it is called upon to fight. To understand why the Kennedy matters so much, you have to understand what broke before it. And to understand that, you have to go back to August 14, 2015, the day workers at Newport News Shipbuilding drove the ceremonial first weld into the keel of CVN-79, committing themselves to a build program that, at the time, was already generating alarm in the halls of the Pentagon. The lead ship of the Ford-class, CVN-78, had been authorized in 2001 and had its keel laid in 2009. By the time Gerald R. Ford was commissioned in July 2017, she'd become one of the most scrutinized, criticized, and problematic warships in the history of the United States Navy. The Government Accountability Office had published a landmark critical report in 2013, GO 13396, which warned in precise bureaucratic language that the Navy had made a catastrophic decision. It had installed no fewer than 23 unproven, immature technologies onto a single ship simultaneously, not iteratively, not in sequence where one system could be validated before the next was introduced, all at once. The result was a $12.9 billion ship that, for years after commissioning, could not reliably do the single most important thing a carrier is designed to do: launch aircraft. The heart of the problem was the electromagnetic aircraft launch system, known as EMALS. For over 6 decades, American carriers had launched their aircraft using steam catapults, massive, violent systems that used high-pressure steam generated from the ship's reactors to propel aircraft from 0 to 165 miles per hour and roughly 300 feet of flight deck. It was brute force physics. Brutal, loud, mechanically demanding. But it worked. EMAS was different. Rather than steam, it used linear induction motors, the same basic technology found in magnetic levitation trains, to accelerate a carriage along the catapult track, transferring that energy into the aircraft with far greater controllability and precision. In theory, EMALS could adjust the acceleration profile in real time, reducing the peak stress loads on airframes by up to 24% compared to steam. It could be maintained with fewer sailors. It could launch a wider variety of aircraft, from the heaviest strike fighters to the lightest unmanned aerial vehicles. The numbers looked transformational. But in June 2020, during a critical testing period aboard CVN-78, the EMAL system suffered a catastrophic fault, a failure in the electrical control architecture. A single-point failure mode that engineers had not fully accounted for rendered all 4 catapults inoperative simultaneously. For 5 full days, the USS Gerald R. Ford sat unable to launch a single aircraft. In wartime, that is not a mechanical inconvenience. That is a dead carrier. The story, when it emerged through reporting by US9 News, sent shockwaves through defense circles. The GO had warned us what happened. They had told the Navy, in 2013, that the reliability and maintainability of EMALS and its companion system, the Advanced Arresting Gear, or AAG, were not meeting required thresholds. The Navy had proceeded anyway. The AAG was, in many ways, an equally ambitious and equally troubled system. Traditional carriers used hydraulic arresting gear, a simple, powerful system where a cable stretched across the flight deck connected to hydraulic cylinders below decks that absorbed the landing energy of an aircraft at 140 knots. It was imprecise, it was heavy, it required constant maintenance. The AAG replaced this with a turbine-based electromagnetic system, essentially a controlled energy sink that could manage landing loads with extraordinary precision, protecting airframes from the violent deceleration shock that had caused structural fatigue in Nimitz-class aircraft over decades of operations. On paper, it was elegant. In practice, it refused to be certified. The turbines behaved unpredictably under certain load conditions. The control software had edge case failure modes that took years to identify and correct. The final certification of AAG aboard Gerald R. Ford was not achieved until deep into the ship's operational life. Well after she had been commissioned and deployed, the advanced weapons elevators presented a third front of engineering battle. The 11 AWEs aboard each Ford-class carrier use electromagnetic linear motors. The same principle as EMALS, scaled and adapted for vertical movement, to transport munitions from the ship's magazine decks up to the flight deck at dramatically higher speeds than the legacy mechanical elevators aboard Nimitz-class ships. The vision was clear. Faster weapons movement meant faster rearming of aircraft, meant more sorties, meant more combat power projected per hour. But the AWEs were plagued with software instabilities, mechanical tolerance issues, and certification failures that stretched across years. The final AWE aboard CVN-78 was not certified until late 2021, 4 years after the ship was commissioned, meaning that for years, the world's most expensive aircraft carrier was operating with improvised workarounds for its own weapons logistics system. Now imagine all of that, the EMALS failures, the AAG certification battles, the AWE software nightmares, and understand that the USS John F. Kennedy was already approximately 20 to 30% constructed when many of these failures were still ongoing and unresolved on CVN-78. This is the engineering tragedy at the heart of the Kennedy's delays. Newport News Shipbuilding and the Navy made the responsible decision to incorporate lessons from Ford wherever possible, but the brutal timeline reality meant that many of those lessons arrived too late to be designed in from scratch. Instead, they had to be retrofitted, rebuilt, or renegotiated into a hull that was already taking shape. In November 2025, the Navy awarded over $142 million in additional contract modifications to HI specifically to fund capability upgrades and engineering change orders. Real money spent to fix, in a mostly complete ship, systems that should have worked from the beginning. The Kennedy also carries one major technological upgrade that the Ford does not. While CVN-70 was fitted with the experimental dual-band radar, a sophisticated but expensive and problematic system that merged air search and fire control functions, the Kennedy will operate with the Enterprise Air Surveillance Radar, designated AN-B6-6 4 V3, also known as EASR. This Raytheon-built fixed-array radar is a derivative of the same SPY-6 family being deployed across the Navy's destroyer and cruiser fleet, designed to provide simultaneous anti-air warfare, anti-surface warfare, and air traffic control functions. The decision to switch CVN-79 to EASR was made in 2015, saving an estimated $180 million compared to the dual-band radar system, and it represents one of the program's genuine architectural improvements. A case where the lessons of CVN-79's radar struggles were successfully incorporated into the Kennedy's design before metal was cut. Through all of this, Newport News Shipbuilding, operating under the HIE corporate umbrella with approximately 26,000 workers at its Virginia facility, pressed forward. The yard deployed modular construction techniques, building the ship in massive superlifts, prefabricated hull sections weighing thousands of tons each that were assembled in dry dock rather than fabricated in place, reducing the complexity of late-stage integration work. The 588-ton island superstructure, the command tower that rises above Kennedy's flight deck, was lifted into place as a single unit, a choreographic feat of precision engineering involving cranes capable of handling loads the size of a commercial airliner. HE outsourced structural component manufacturing to 23 facilities across the country, including a newly acquired plant in South Carolina, in an effort to increase throughput by 10 to 15% and free Newport News workers for the highly specialized nuclear and combat systems integration work that can only be performed in one place on Earth. The workforce itself became a battleground. As wages in technology, construction, and manufacturing rose dramatically in a post-pandemic labor market, Newport News struggled to retain the experienced shipbuilders whose institutional knowledge is irreplaceable. The welders who know the feel of a perfect nuclear-grade weld. the electricians who understand the idiosyncrasies of high-density power distribution in a nuclear warship, the systems integrators who understand the idiosyncrasies of high-density power distribution in a nuclear warship, the systems integrators who carry years of earned wisdom about how a carrier's million interconnected components behave under operational stress. HE President Kerry Wilkinson, who took over Newport News and began implementing aggressive retention programs, acknowledged in December 2025 that keeping talent was a constant fight. People have lots and lots of alternatives these days, she told USNI News, and to make a comparable wage in shipbuilding is hard. Wage increases funded partly through the last Block V Virginia-class submarine contracts began reversing the attrition trend. But the damage done in the preceding years, measured in delayed milestones and lost institutional memory, was already embedded in the Kennedy's construction timeline. By the time the ship underwent its 5-day fast cruise, a full pierside simulation of underway operations conducted in late January 2026 where the ship is brought to life, all systems energized and operated as if at sea, but without leaving the dock. Approximately 5,000 sailors of the pre-commissioning unit had been aboard, training alongside the shipbuilders, learning every commissioning unit had been aboard, training alongside the shipbuilders, learning every compartment, every circuit, every emergency procedure. Captain Langenberg later reflected on what that moment represented. There are millions of fingerprints contributing to this successful sea trial, he said. Both of the hard-working patriots who built this great ship and of the sailors who are now bringing her to life. He was not being rhetorical. He was being precise. A Ford-class carrier contains approximately 4.5 million individual parts. Every single one of them had to be right. January 28, 2026, 0600 hours. The PCU John F. 28. Kennedy, still technically a contractor asset, not yet property of the United States Navy, clears the pier at Newport News Shipbuilding and begins her transit down the James River toward the open Atlantic. The ship moves under her own nuclear propulsion for the first time in her existence. Below decks, in the engineering spaces, where two A-1B nuclear reactors generate more electrical power than a medium-sized city, approximately 600 megawatts, 3 times the electrical output of the Nimitz-class reactors. Engineering watch standards monitor gauges and readouts with an intensity that cannot be faked. These are not dress rehearsals. Every anomaly, every unexpected reading, every vibration that shouldn't be there, is logged, evaluated, and reported in real time. The builder's sea trials, BST in Navy parlance, are the first comprehensive evaluation of a new carrier systems in the actual operating environment they were designed for. A steam catapult test rig feels different from a land-based test facility when the ship is rolling in Atlantic swells at 12 knots. The AAG's turbines behave differently when the ship's deck is pitching 2 degrees. The AWEs respond to command inputs with different latency profiles when the hull is flexing slightly under seaway loads. This is the brutal, irreplaceable truth of naval engineering. You cannot simulate the ocean. You have to go to it with your ship, your systems, and your sailors and find out what doesn't work. The 7 days between January 28 and February 4 were not a victory parade, they were a systematic discovery process. Working side by side, HIE shipbuilders in their hard hats, PCU sailors in their dungarees, supervisors from the Navy's subship organization, technical representatives from Naval Sea Systems Command and the Program Executive Office aircraft carriers. The team ran Kennedy through a battery of test events designed to stress every major system under real operational conditions. Propulsion was evaluated across the speed range. Electrical distribution systems were loaded and stressed. Navigation, communication, and combat system architectures were brought online and exercised. The EASR radar was powered and evaluated. Damage control systems were drilled. The anchor was dropped, a deceptively complex evolution for a 100,000-ton ship, in an exercise captured in photographs that circulated widely on Navy social media. Rear Admiral Casey Moten, the Program Executive Officer for Aircraft Carriers, captured the significance of the moment without equivocation. Seeing this Navy industry team take CVN-79 to sea for the first time was nothing short of thrilling, he said in the official press release issued February 4, 2026. Thanks to the tireless efforts of thousands of proud American workers across the maritime industrial base, we are one step closer to delivering another Gerald R. Ford-class aircraft carrier to the fleet. The language was careful, one step closer, not mission accomplished, because the BST, while successful, was precisely what its name implied, a builder's trial, conducted before the Navy formally accepts the ship. The real crucible. Acceptance trials, conducted by the Naval Board of Inspection and Survey, still lay ahead on the timeline described in Navy documents only as currently under review. What made these trials particularly significant was what sailors reported about the ship's automation architecture. Unlike the Nimitz-class carriers, which were designed in an era before distributed digital control systems existed, the Kennedy was built from the outset with an integrated computer automation framework that dramatically reduces the human manning burden for routine system monitoring and management. Warrior Mavens reporting on the sea trials noted that sailors were excelling specifically with this computer automation, that the crew's ability to manage the ship's complex systems through digital interfaces was performing at or above design expectations. This is not a trivial data point. The Ford class was designed to operate with approximately 27% fewer crew members than the Nimitz class, roughly 600 fewer sailors on a deployed carrier, not because the Navy wanted to cut jobs, but because modern carrier warfare demands that human attention be focused on complex tactical decisions rather than on the laborious manual monitoring of thousands of mechanical systems. If the automation is working, those 600 sailors represent an enormous strategic advantage. They can be elsewhere in the fleet, on submarines, on destroyers, on the cruisers and amphibious ships that are stretched dangerously thin across the Pacific and the Middle East. Meanwhile, in the spaces aboard ship where the AAG and AWE systems resided, the engineers and sailors engaged in a far more nuanced and pressured evaluation. These were the two systems whose certification failures had already pushed Kennedy's delivery date from July 2025 to March 2025 to over Nelwar 27 Apt, a two-year slip worth billions in delayed operational capability. The Navy had been brutally transparent about this in its FY 2026 budget documents, stating explicitly that the delivery date shift was driven by completion of advanced arresting gear certification and continued advanced weapons elevator work. Every senior officer involved in the program was acutely aware that these systems had already broken the Ford and had come dangerously close to breaking the Kennedy's timeline entirely. The sea trials were, in part, a live demonstration under real conditions that the years of rework and redesign had produced something that worked. What the BST revealed, and what subsequent completion work addresses, is that these systems are maturing. They are not the frail, temperamental prototypes that frustrated the Ford's early operational years. The AAG turbines, refined through years of engineering iteration and operational feedback from CVN-78, were responding predictably. The AWEs, their software rebuilt and their mechanical tolerances tightened, were operating within certification parameters. This does not mean the work is done. Captain Mark Johnson, the program manager for Gerald R. Ford-class new construction, chose his words with precision after the trials concluded. We continue to work closely with the shipbuilder to ensure that the nation's next aircraft carrier is delivered to the Navy on the fastest possible path to combat readiness. Fastest possible path, not the scheduled path, the fastest possible path. Because somewhere beyond the horizon, a war is being fought, and the calculus of urgency has fundamentally changed. The sailors of PCU Kennedy know this. They've been living with the ship, many of them for 2 or 3 years, assigned to the pre-commissioning crew while the vessel was still being finished around them, and they carry a mix of pride and pressure that is difficult to articulate to anyone who hasn't stood on the flight deck of a 100,000-ton nuclear warship and understood, viscerally, what it will be asked to do. Sailors who trained on simulator rigs with the AWEs, providing direct operational feedback that shaped the system's certification process, describe the experience to NAVSEA reporters as both technically demanding and personally urgent. These are young men and women in their 20s, many of them on their first sea tour, who understand because they've been briefed and they read the news, that this ship may not remain a peacetime platform for long. The F-35C compatibility built into Kennedy's design is not an abstraction in this context. The F-35C Joint Strike Fighter, the carrier variant of the most advanced stealth combat aircraft in the American arsenal, is precisely the kind of platform that transforms a carrier strike group from a potent deterrent into a near-invincible one. Its combination of low observable stealth, sensor fusion, and long-range precision strike capability, integrated with Kennedy's EMALs, which can launch F-35Cs with programmable acceleration profiles that reduce stress on the aircraft's airframe, creates a synergy that the Nimitz-class ships launching F-Prime creates a synergy that the Nimitz-class ships launching F-A-18s on steam catapults designed before the F-35 existed simply cannot match. When Kennedy finally deploys operationally, she will not merely replace the Nimitz. She will be categorically superior to anything currently in the fleet. On February 4, 2026, PCU John F. Kennedy eased back into her berth at Newport News Shipbuilding, having completed builder's sea trials. The tugs nudged her home. The lines were secured, and the team, sailors, shipbuilders, program managers, contract officers, and the thousands of workers across 23 manufacturing facilities who had contributed components now assembled in one hull, took a breath. One milestone achieved, many still ahead. The strategic situation waiting for that ship had, in the weeks between the Kennedy's sea trial departure and her return, grown more complex and more pressured. News of the USS Nimitz's service life extension, driven explicitly by the ongoing conflict with Iran, according to reporting from multiple defense outlets, circulated to the carrier community like a cold wind. Here was the living, aging embodiment of the problem Kennedy was designed to solve. A carrier that should have retired, kept at sea because the ship meant to replace her was not yet ready. The Nimitz Gap, a phrase that had circulated in defense policy circles for months, describing the period when the fleet would dip from 11 to 10 carriers, had been partially bridged by the extension decision. But the extension ends in March 2027. Delivery of Kennedy is targeted for the same month. There is no margin for error. There is no buffer in the schedule. If Kennedy slips again, if the AAG certification fails, if the AGS certification fails, if the POEs throw another anomaly, if post-sea trial completion work reveals unforeseen structural or systems issues, the Navy will face a gap in carrier availability precisely when the geopolitical environment demands maximum forward presence. This is the strategic weight carried by a single ship. This is why the engineering decisions made in Newport News over the last decade matter beyond the shipyard gates, beyond the Navy budget battles in Congress, beyond the technical papers and geo reports that have chronicled every delay and every failure. The USS John F. Kennedy is not simply an aircraft carrier. She is a node in a global deterrence architecture. She is the embodiment of American willingness to project power, and the consequence of failing to deliver that embodiment on time is measured not just in dollars, not just in carrier gap statistics, but in the behavioral calculus of adversaries who watch American military readiness with extraordinary attention and who will make different decisions depending on whether they believe that American naval power is coherent, capable, and present. Consider what Kennedy represents in operational terms when she does deploy. Her sortie generation rate, 160 sustained sorties per day, with surge capability toward 270 compared to the Nimitz class's 120 sustained and 240 surge, translates directly into combat power. Every additional sortie per day is another F-35C or FA-8 need over a target, another set of precision munitions delivered on a threat, another hour of combat air patrol over a contested maritime corridor. The AWEs, when fully operational, will cycle munitions from magazine to flight deck at speeds that reduce the rearming time per aircraft, compressing the cycle time between a returning strike aircraft and its next launch. The AAG's precision energy management protects aircraft airframes from cumulative fatigue stress, extending the operational life of every jet aboard. These are not marketing points. They are tactical multipliers with quantifiable operational impact in exactly the kind of sustained, high-tempo strike campaign that the Iran conflict may demand. The EASR radar, the Enterprise Air Surveillance Radar, the Enterprise Air Surveillance Radar, the SPY-6V, FREATS, adds another dimension that is easy to understate. The same radar family being deployed on Arleigh Burke destroyers and future cruisers, now integrated into Kennedy's fixed panel array, provides a level of air and surface picture quality that the Nimitz-class carrier's older radar architecture simply cannot generate. In a contested maritime environment where adversary anti-ship cruise missiles fly at sea-skimming altitudes and hypersonic threats require detection at maximum possible range, the quality and processing speed of your radar picture is not a marginal advantage. It is the difference between having time to engage a threat and not having that time. Kennedy's EASR was designed with this reality in mind, and its integration into the ship's combat management system creates a sensor-to-shooter timeline that represents a generational improvement over legacy carriers. What is the lesson? What does a decade of pain, delay, and reinvention teach us about how great powers build the instruments of their own security? The first lesson is the oldest. There is no shortcut from ambition to capability. The decision to install 23 unproven technologies simultaneously on CVN-78, made with the best intentions, motivated by the genuine belief that transformational capability required transformational risk, turned a flagship program into a cautionary tale and a congressional punching bag. The engineering community knew the risk. The GO warned about it. Operational testing experts raised flags at every stage, and the program pressed forward, because the pressure to deliver a revolutionary platform within a bounded budget and schedule is always greater than the pressure to be honest about what revolutionary actually costs. Kennedy is paying that debt. The $142 million in late-stage contract modifications, the 2-year delay, the retained Nimitz, these are the compound interest on a loan taken out in 2001 when the Ford-class program made its first optimistic assumptions. The second lesson is about the inescapable value of operational feedback. The systems aboard Kennedy, the EMALs, the AAG, the AG, the AGBEs, are not the same systems that broke the Ford's early operational record. They've been rebuilt, refined, and matured through years of real-world experience that no simulation or land-based test could have generated. The Ford's EMALs, which failed catastrophically in June 2020, had by 2022 achieved a mean time between operational mission failures of 614 cycles. A dramatic improvement over its earlier performance, driven by precisely the kind of iterative, failure-driven learning that only happens when a system is pushed hard by real operations in real environments. The sailors who trained on Kennedy's AWEs, who provided hands-on feedback that shaped the system's final certification process, are participants in a learning loop that ultimately produces more reliable weapon systems than any amount of pre-delivery bench testing can achieve. It is expensive. It is frustrating. But it works. The third lesson is about the human factor. The 26,000 workers at Newport News, the 5,000 sailors at the PCU, The program managers and contracting officers and technical representatives whose names will never appear in a press release, but whose judgment, skill, and commitment are the actual substance of national defense. Kerry Wilkinson's fight to retain shipbuilders against a competitive labor market is not a human resources story. It is a national security story. The knowledge that lives in the hands and minds of an experienced nuclear shipbuilder, the tacit knowledge that cannot be written in a manual or captured in a training program, the kind of knowledge that only accumulates across years of doing the same hard, precise, dangerous work, is a strategic asset as surely as any radar system or electromagnetic catapult. When that knowledge walks out the door, it takes years and hundreds of millions of dollars to rebuild. The Navy's industrial base is not a support function. It is the foundation upon which every other military capability rests. And the fourth lesson, perhaps the most uncomfortable one, is about the cost of falling behind. The USS Nimitz, 51 years old in 2026, retained in service by a conflict no one fully anticipated, is a monument to the consequences of delayed modernization. She is serving with honor, crewed by sailors who have given everything to keep her mission capable. But she is also a reminder that the most powerful nation on Earth cannot afford to let its most critical military platform slip from the timeline, cannot afford to cut corners on industrial capacity, cannot afford to underfund the shipyards, the workforce development programs, and the engineering programs that translate national treasure into operational capability. Every delay in Kennedy's delivery is a day the Nimitz must remain at sea, burning through her remaining service life and the health of her crew to fill a gap that should not exist. When the USS John F. First Kennedy is finally delivered to the United States Navy in March 2027 when she completes her acceptance trials. When the Navy's Board of Inspection and Survey stamps her fit for service, when her nuclear reactors carry her out of Hampton Roads under the flag she was built to serve, she will represent something larger than a single ship. She will be the resolution of a decade-long argument about what America's naval power can be and should be. She will validate the engineers who refused to accept that EMALS was fundamentally broken. She will honor the shipbuilders who bent metal through a pandemic with COVID-19 raging around them. She will vindicate the sailors who trained on her systems for years before she was ready to take them to sea. And she will send a message to every adversary watching from Tehran to Beijing that the United States has not lost the ability to build what it needs to defend what it values. That message is not delivered by a press release. It is not delivered by a congressional hearing or a think tank report or a defense budget document. It is delivered by 100,000 tons of nuclear-powered, electromagnetically armed, stealth-capable, sea-sovereign American engineering sailing over the horizon at 30 knots, ready to generate 160 sorties a day until the fight is over. The Kennedy is coming, and she has them worth every single day of the wait.